All right, homework 8.3, problem number 2. All right, so we have a triangular plate is submerged in the water, and I guess base is 2 meter and height is 4 meter. All right, so let's look at step 1. All right, so we have, let's see, so this is at depth xi star, and we are looking at the width here. Well, that's going to be wi. And we're looking at the ratio between Wi to 2 is going to be, the height is xi star to the height of the big triangle is 4. So this is going to be 4 right there. All right, then if you solve for Wi, it's going to be 1/2 xi star. So it's going to be 1/2 xi star times delta x is going to give you the area of the approximating rectangle. So I'm going to just put 1/2 here. All right, so let's submit. All right, it came back and looks like we got the step 1 correctly. All right, so let's look at the step 2. Using density, so this is going to be a mass density and gravitational constant g. So then pressure on the strip. All right, so remember that the pressure is going to be a weight density times the depth. Depth in this case is xi star. So, and this is a mass density, so you have to multiply by g. So we're going to have to write rho. Let's see, I have to look for the special character. I guess it's a Greek letter. And then we're going to have a rho times g. All right, so I'm going to just put g there. All right, so rho g is like a delta we used in class. So this is the weight density, and times the depth gives you the pressure at the depth xi star. So let's submit here. All right, it came back and looks like we got the step 2 correctly. All right, so let's look at the step 3, hydrostatic force on the strip. All right, so hydrostatic force would be a pressure, which we found that to be 1/2 xi star delta x times, actually that's the area, right? And then times the pressure. Pressure is rho g xi star. So this is going to be 1/2, and let's see, it's 1/2. So how about that? 1/2, and I'm gonna have to put rho here. So Greek letter and the rho and the g, and xi star times xi star, so there's a square there, delta x. All right, so all we did was just to multiply this step 1 and step 2 together to get that. All right, let's submit. All right, I came back and we got the step 3 correctly. All right, then we just have to, so this is the hydrostatic force on one strip. So we just need to add them up. So it's going to be n here, and you just put the hydrostatic force for one piece. So let's submit here. All right, it came back and looks like we got the step 4 correctly. All right, then we need to do an integral, and remember I have to go back. All right, so original triangle has the height of 4 meter. So you're going to have to start from 0 to 4. All right, then let's see, rho g is pulled out here. So you would have to have x squared over 2. So I'm going to just put x squared and over 2, and the delta x becomes dx. All right, so let's submit here. All right, it came back and we got the step 5 correctly. All right, so let's move on to step 6. All right, so we just need to evaluate this. So 1/2 is pulled out, and rho and g is sitting here. So antiderivative of x squared would be x cubed over 3. All right, Then we just plug in 4 and divide by 3. So that's let's see. If you plug in 4 cubed, right? But this is over 2. So let's see, 4 times 4 is 16. 16 times 2 is 32. So 32 over 3. So 32 over 3, right? And then rho G Newton. And let's submit. All right, I came back and we got the step 6 correctly. And now let's do step 7. All right, so we just have to find, let's see, we have to find a whole number. So you're going to have, let's see, 32 over 3, all right? Then multiply by rho would be 1,000 kilogram per cubic meters. And then multiply by G is going to be 9.8 meters per square second. So let's put that in here, right? Oh, actually, I have to go to option. Let's see. Oh, actually, maybe I have to go here and object property and algebra. Instead of symbolic, that'll give you the fraction form. So here. So we have, let's see, 104,533. Right? 104,533. Right? So let's submit the answer. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.